Welcome to our video going over the study guide for our little mini unit in 5B, operations on functions. So this is intended to be a smaller assessment than what you would normally get because it is like a mini unit. It was only 4 lessons long, so hopefully the video will be a little bit shorter, and this will give you a good review if you are absent on our review day or if you were here on the review day but still want to go over the problems some more. So I actually grabbed this straight from the study guide, which was written directly from the quiz itself. So basically going through the quiz versions and I'm changing up the numbers and then went and changed up the numbers again to create the study guide. So this is a pretty reliable, this is a pretty reliable picture of what you will see on the quiz. So for problems 1 through 7, given f of x equals 3x squared minus 13x minus 10 and g of x equals 3x plus 2, perform each of the operations as shown. Show all work that you do. Work is required for multiplication, division, and composition. So for our multiplication problem, for our division problem, and our composition problem, and then probably for number 7 as well, you need to do something to get there. The other 3, it's possible that you could look at those functions and do those things in your head. Not recommended that you would do it that way, but they're the kind of problems where you can make the case like, oh, Miss Taylor, I did that in my head. The other ones, I need to see something, okay? So for the first one, f plus g. So for f plus g, I think I have 4 duplicate slides here, so I can kind of spread out my work. So we have f, which is 3x squared minus 13x minus 10. And we're going to add to that g, which is 3x plus 2. And when you're adding, you can just remove the parentheses. They are cosmetic. They set the 2 functions apart, but mathematically, if you're just adding stuff, it doesn't do anything. Remember to combine your like terms. So we have 3x squared. Looking at our x terms, negative 13x plus 3x would give me negative 10x, and then negative 10 plus 2 is negative 8. And so when I add them, I'll get 3x squared minus 10x minus 8. Okay, so there's our adding f and g. Next one is subtracting them. So f minus g. And for this, your parentheses are not cosmetic. So while it is possible to do this in your head, I do not recommend. Okay, so f minus g, let's go ahead and remove those parentheses. And we'll have minus 3x, and of course minus a negative right here. Minus the negative is going to give us a positive 2. And then looking for our like terms, we'll have 3x squared. This time I have negative 13x minus 3x, which will give me negative 16x. And then, oh, wait a minute. Hang on. I made a mistake. I copied it wrong. That should be a plus, so that should be a plus, which means that should be a minus. Now, what just happened there? One, your teacher copied something wrong. But what I want you to notice when I copied it wrong is because I've done a whole lot of these, when I got to this point right here and it was negative 10 plus 2, I recognized like, wait a minute, I just did that, negative 10 plus 2. I was doing negative 10 plus 2 when I was adding them together. Therefore, it should be different. And that's what caused me to kind of hold up for a second, like, wait a minute, I just saw that. Like, I literally just saw negative 10 plus 2, and I know that if I'm subtracting it, it shouldn't be the same thing. And so you can do the same thing when you're taking your test. If you're paying attention to the problems and paying attention to what you're doing, you know that subtracting and adding are different operations. Therefore, like, it should be different. And so that's why I caught it there. And just go back and look and be like, wait a minute. And probably half of you watching the video were like, you copied it wrong. Yep, apparently I did. All right, so what am I doing here? So we have negative 10 minus 2, which would be negative 12. Now, if you're following along at home, hopefully you're writing this down, okay? You're writing this down because writing is going to be an added layer of review on top of hearing and seeing. Okay, so you have hearing, seeing, and then the doing. I know we like to think, oh, hands-on stuff. Like I learned with hands-on stuff. Writing is hands-on. It's not exciting, but it is hands-on. So notice that we have positive 3x squared minus 16x minus 12. Okay, just notice that. So we have a positive and then two negatives following it. My next slide, I'll start off with g minus f. So for g minus f, we're going to switch the order. Okay, so we're going to have 3x plus 2 minus 3x squared minus 13x minus 10. And remember, when you remove your parentheses, that subtraction goes with everything. So you're going to have minus 3x minus a negative is going to make it adding, and then minus a negative over here is going to make it adding. So plus 13x plus 10. Now looking, oh, the square didn't come out there. Looking for our like terms, we have negative 3x squared. Now I have 3x plus 13x, which is 16x. And I have 2 plus 10, which is 12. And take a moment and just compare that answer with the answer that we had on the previous slide, which was positive 3x minus 16x squared minus 12. And this one is negative 3x squared plus 16x plus 12. So when you switch the order of your subtraction, I don't like my subtraction symbol up there. There we go. When you switch the order of your subtraction, literally everything flips the sign, like everything. So you should have the same expression just with all the signs flipped. Next one is multiplication. So while it is possible that you could have done these last few in your head, I will accept it if you just go straight to the answer. Now, if you subtract like f minus g and you're super confident that you did it correctly, you can just flip the signs and get g minus f. That's fine to do. I wouldn't on a quiz. And the only reason I wouldn't on a quiz is not because it doesn't work. It's just because a quiz is higher stakes. And if you carry out the subtraction in both directions, what will happen is it'll serve as a check. Okay, so you'll get that little extra bit of confidence that you did do it correctly and you didn't make any sign errors if you get this pattern. Which on your homework or something maybe doesn't matter as much, but when you're doing something that's higher stakes, like I would take the time to do it. So number 4 is multiplication. So we are going to multiply on our area model. That is how we've been doing it this year. I'm going to write f across the top. So 3x squared minus 13x minus 10. And then we're going to have 3x plus 2. Okay, and then to multiply, we'll find the area of each of the smaller rectangles, and then we have to add them up. So 3x times 3x squared is 9x to the third. 3x times negative 13x is negative 39x squared. And then 3x times negative 10 is negative 30x. Next one down, 3x squared times 2 is 6x squared. Negative 13x negative 13x times 2 is negative 26x. And negative 10 times 2 is negative 20. And remember that we do want to add all of those up. And our like terms, conveniently enough, are on the diagonals because these were in standard form with nothing missing. So we will have 9x to the third. Negative 39x squared plus 6x squared is negative 33x squared. Negative 26x minus 30x is negative 56x, and then minus 20. Okay, yay. And you may use a calculator for your in-class test. I'm doing it without a calculator. I'm not going to guarantee my work when I'm not using a calculator because that would be silly. But I mean, I can do it without a calculator. So there you go. So there's your multiplication. And this is where we really get past what is doable in your head. So if you were to suddenly, come to me and say, oh, well, I did it in my head, I am going to grill you pretty hard about it. Where did you get a negative 56x from? What were the terms? What were the procedures that went into getting that negative 56x? So if you're going to try that, make sure that you are ready to defend that answer, okay? All right, so moving on to the next one, which is division. So we're going to do F divided by G, and for this one, we are going to use the area model again, except in this case, the number of columns is going to be equal to the degree, so I need 2 columns, and I'm going to be dividing by G, so we're going to be dividing by the 3x plus 2. And if you're not sure about the number of columns and stuff, you can just add extra columns. What will happen is you'll just have extra columns, like you'll finish the problem before you're done with columns, and that's fine. You just ignore the extra columns. No biggie. All right, so when you're dividing, in this case, we know the area. So we know what the area is. The area is 3x squared minus 13x minus 10. We know one of the dimensions and we're looking for the other dimension. On the polynomials test, there were a lot of students that just multiplied everything all the time. So the area model, you're like, I'm multiplying. The area model works for multiplying. We just did it for multiplying, but it also works for factoring and works for division, and it works for other operations other than multiplying. So make sure you are paying attention to which operation you have and then using the model appropriately. So if you're multiplying, you have one factor and then the other factor, and you're multiplying them to get the area. If you're dividing, you know the area and you know one of the dimensions and you're looking for the other dimension. Okay, rewind that if you need to hear me say that again. Maybe I'll say it again anyway. If you're multiplying, you know the base and the height, and you're looking for the area, because area is base times height. If you're dividing, you know the area, we'll say the height, and you're looking for the base. Okay, it's the difference between area equals base times height and base is equal to area divided by height. Okay, in one of them, you know the base and the height and you're looking for the area, so you're going to multiply. In the other one, you know the area and you know the height and you're looking for the base, so you're going to divide them. So without further ado, we'll go ahead and plunk that 3x squared right into that upper left-hand corner, and we ask ourselves, 3x times what gives me 3x squared? And hopefully your answer to that is x. And then we multiply to get the 2x. Now, these two need to add up to give us negative 13x, because we know the area. The area is 3x squared minus 13x minus 10. And so we need this to come out to negative 13. Well, I have a positive 2. If I want to add it to something to get negative 13, that's better be negative 15x. Okay? And again, because negative 15x plus 2x is where we would get that negative 13 from. 3x times what would give me negative 15x? Well, that would be negative 5. And then negative 5 times 2 is negative 10, which is nice. That means that that divided evenly. Okay, it divided evenly, so we did not have a remainder. If we did not get a negative 10, we would need to have a remainder, probably written out here, that would make it come out to negative 10. Now, before you leave the problem, though, make sure that you indicate what the answer is. So in this case, the answer is x minus 5. So unlike, just like with the multiplication one, we had the area model, and then we had this like space off to the side. We need to make sure we write the answer. Which part of the area model is your actual answer? Okay, next one is composition. So this is G of F. This is G of F. Now, when it comes to composition, remember that sometimes it's easier in one direction than the other. And so we're going to start this off with, like, it's G of F. So we're going to start by writing down function G. And then we're going to take function F and plug it into function G. You might observe that this is the easier of the two directions. Okay, and if it's the easier of the two directions on your study guide, probably it will be the easier of the two directions on your test, because your teacher isn't going to set you up preparing you with something easy and then kind of surprise you like, oh, by the way, we're gonna have some like foiling skills or some other stuff going on your test. Okay, that makes it just hard for those of you that really do take the study guide seriously and you try to prepare. You're kind of trusting that the study guide is going to help you prepare. It's not going to leave stuff uncovered. Okay, now before we leave this, we do want to simplify it. So 3 times 3x squared is 9x squared. 3 times negative 13 is negative 39, so negative 39x, and then this will be minus 30. And then you can take that minus 30 and that plus 2, and that'll give us negative 28. Okay, please work top to bottom. On the day that I'm recording this, I actually finished grading the Unit 5 tests the day before, so I graded them yesterday and the day before yesterday. And one of the things that was really weak was structure of the work. So your work should go top to bottom, always top to bottom. If you are stringing it out left to right, it's very hard for me to see when one step ends and the next step begins. And on the page, on the layout of your page, you're actually putting work that's related to each other far apart on the page. So when you go top to bottom, okay, you've got like the 3 minus 3x squared, and instead of writing that way over here somewhere, you're writing 3 times 3x squared. The answer is like right here, so physically it's in close proximity to the work that generated it as opposed to being way over there. Okay, all right, and last one of these is f of g of 1. So for f of, oops, let me change it over again. So for f of g of 1, it would be really useful if we came over here and found g of 1. And so we're going to go ahead and plug the 1 in. And so that's 3. 3 plus 2 is 5. So g of 1 is 5. So really, that is f of 5. And so we're going to have 3 times 5 squared minus 13 times 5 minus 10. This will be 3 times 25. So remember your order of operations, you're going to square first. So 5 squared is 25, and 3 times 25 is 75 minus, what is that? 13 times 5, so 10 times 5 is 50, and 3 times 5 is 15, and 50 plus 15 is 65, so minus 65, minus 10, and then 75 minus 65 is 10, and 10 minus 10 is, is 0. Okay. I should have put in this video presentation a link to Desmos. You can actually do this on Desmos as well. So what you can do on Desmos is type in f of x equals g of x equals, and then literally type in like the operations that you want, like f of g of 1 into Desmos, and it'll spit the number out for you. Now you can't use Desmos on your in-class test, but you could definitely do it on your final or on your at-home test. So yay. F of g of 0. What was the oh yeah, okay, that makes sense. I'm looking at my factors. It ties into the problem number 5 there. All right, so there's all 7 of those with all the work done out. Let's move on to some other stuff. One of the benchmarks this year is that you need to be able to carry out function operations with things other than just equations. So other than just equations, if the function is represented on a table or on a map or a set of ordered pairs, like just different ways that a function can be represented, that you are able to interpret those. So on your at-home test, you're going to see some tables for doing it on your in-class test, we're going to give you some maps. So on numbers 8 and 9, perform the indicated operation given the maps. So we have for number 8, f of 10 plus g of 13. So to do this, we're going to come over here and find f of 10. So what that means is that x is equal to 10. So there's x is equal to 10. There's my value. So this would be 100 plus, and then we got to do the same thing over here, g of 13, and we come over here, x is 13, so g of 13 is 5, and so my answer would be 105. And essentially, like, that's a pretty basic addition problem. What it's assessing is whether you know what to do with the map, like you know what the x and the y and how they're related. The second one there is g of f of 3. So just like with the last one where we started with the inside part, I'm going to start with f of 3. Okay, and so coming over here to look at f of 3, f of 3 is 9. And so f of 3 of 9, so this is essentially going to be g of 9, which is -3. And there's your answer. Okay, so I actually think that's the only one that you can do with these particular maps. I was like scrounging for these maps, and I think 9 is the only number that appears in the range of 1 and also in the domain of the other. Yeah, so, so that's the only composition problem I can write with these maps, but it's good. It's all good. At least we got our review in. So there we go. Okay, so that's with the maps. Okay, next one, find the inverse function or find the inverse of the function shown, show all work. So notice it does say that you need to show all work. Okay, so I need to see this process and I need to see it done and laid out the way that we did it in class. Okay, so it needs to go like top to bottom, left to right, the good structure. If you can't tell, that was a serious issue on the last test. So hopefully you'll go back and review this in your notes and such. But first thing in finding those inverses is if you have an f of x, go ahead and change it back over to a y. Okay, it's just a little less clunky. And the way inverses work, like where they come from, is they come from switching the x and the y coordinates. So you could like switch them on the individual ordered pair level, so this like in the little parentheses, or you could switch them on a more generic, like big level by actually switching the variables around. And now we need to solve for y. So I'm going to go ahead and subtract 5. So that'll give me x minus 5 equals 5y. And then there's a little bit of flexibility here. You need to divide by 5. I will accept this as an answer. So we'll change that notation over. I will accept x minus 5 all divided by 5, indicating that you're dividing the entire thing by 5. Honestly, if I were you, that's where I would stop it, given that my teacher has just said that she will give me credit for that. I'm not going to try to go further. However, in this case, you might want to do this. That means it's like x divided by 5 and also 5 divided by 5. In other words, we're dividing everything. This will end up being like that's a 1 in front of the x there. So it ends up being 1/5 x minus 1. This way of writing it right there is useful if you wanted to graph it using slope-intercept form. Okay, that would be useful, but if the directions just simply say find the inverse, you want to find the inverse and then probably stop. Okay, now if you're watching this and you are not my student, so you're watching this for fun, you want to always listen to what your teacher says that you should do or how they're going to accept their answer. I will absolutely get picky about that notation. Okay, I will get super, super picky about that. So if you leave it as a y, you are going to get a deduction for that. Okay, just to be really clear, for me, you will get a deduction. All right, number 11, determine if functions f and g are inverses using the method of your choice, except Desmos. So because you're not allowed to have access to the internet during your in-class tests, that's going to be off the table, except Desmos. So, but you must show all work and explain how you know from your work whether the functions are inverses. So you're going to say like, yes, they are inverses and no, they are not, and then say because. They are inverses because, or they are not inverses because. There are different ways you can do this. Some people will take the, we'll go through it because we got time. What else are we going to do? So one of the ways you can show whether they're inverses is by taking one of the functions. So I'm going to take this one right here and finding the inverse. Okay, so I switch the x and the y. And then I'm going to divide by 4, and I'm going to end up with this x plus 1 over 4. Now, I want to be a little careful because what I've got to do is I've got to compare it with this and see if that's the same function. So you've got here 1x. So that's going to translate into 1/4 x, but then you're going to have 1/4. And so you're going to notice that that has a +2, this has a plus 1/4, and so our answer is no. And then I would explain it, no, because like I found, oh, that's not going to show up. I found F inverse and it is not G. Okay, so you're going to say no, they are not inverses because I found F inverse and it is not G. Now, if you go and find the inverse and it is G, then you would say yes, because I found F inverse and it is G. It is the same function as G. So you're going to determine whether or not they're inverses, and then you have to explain why. So this is one of the ways that you can determine if something is an inverse. Okay, so I'll kind of leave, I'm going to erase my explanation. I'll leave that up there at least for the time being. Another way you can do it is using composition, and this is probably like the approved way. So we're going to do fog, which means I'm going to start by writing down F, and then I'm going to take G and plug it in. So I'm going to have 1/4 x plus 2 and then minus 1. 4 times 1/4 is x. 4 times 2 is 8. And then 8 minus 1 is 7. Okay, and then we would have to answer once again, no. But this time my reasoning is different because I'm using a different way. No, because fog is not equal to x. So if you compose them and you get anything other than just an x, they are not inverses. So no, because f of g of x is not equal to x. Now, if you compose them together and it is an x, you cannot say yes until you do the other composition, okay? So you would have to do fog, and then you would do goff, you'd do the other direction, and then you would say yes, because fog and goff are both x, okay? F of g of x and g of f of x are both x. And so you would have to do them both, okay? Just heads up if that's the direction you want to go with that. Now, the other way you can do this, and this would not be a proof. I think both of these are solid, so I would strongly recommend that you do one of these. But if the question is, are these inverses, and you are allowed to pick your method and you're trying to come up with an answer here, you could do it this way. You could pick a value for x, okay? Say x is equal to, oh, what might I want it to be equal to? Nothing is going to come out nice. Let's make it equal to 0 then. So I'm going to plug in, actually I'm going to do it this way. I'm going to do g of 0, because mostly I'm doing that because I don't want to deal with that fraction. Plus 2, okay. And then 0 times 1/4 is 0, and g of 0 is 2. Now, if I take the 2 and I plug it into f, I get 8 minus 1, and I end up with that 7, okay? Which is interesting. Huh. Okay, I'm seeing a pattern there that I'm not sure it might be coincidental. I don't know. It's the problem with this strategy. Now, in this case, you would say no because. Okay, so so for this one, you would say no because f and g do not undo each other. Okay, which is what inverse functions should do. They should undo each other. And in this case, they don't. Now, if you plug in a number and you get like the 0 back, okay, so if we plugged in a number, you get like g is equal to whatever, and you plug that into f and you get the 0 back again, you want to be careful about how you phrase it, because you would want to say yes because f and g appear to undo each other. I would honestly, if you're going to opt for that last strategy, I would pick more than one number. I would definitely pick more than one. You can hear me like looking at right now, just recording the video, and I'm looking at those numbers and I'm seeing a pattern, and I'm not totally sure if like what I'm seeing is something that's going to hold up. I would need to stop and look at it more closely. So be careful about how you phrase it. And I would definitely pick more than one number, okay? Because you want to make sure you didn't pick like the one number that they would look like they undo each other, and then it turns out they actually don't. Okay, now just because the study guide has a pair of functions that are not inverses doesn't mean that the pair on your test would not be inverses. So as we are reviewing this, I'm going over like this is what it looks like in this particular problem, but here's how you would respond, or here's how you would answer, and what you would look for if they were inverses. So we are covering that in this review. That means that is fair game for your test. Okay, so you might answer no, you might answer yes, and then you have to explain why. All right, last question. Sketch the inverse of the function. So we've done this. There's actually two ways you can go about sketching the inverse of a function, especially with this kind of graph. And I'll kind of go through it both ways. First of all, when you're sketching the inverse, one of the ways you can do it is by locating the ordered pair. So for example, this point right here is the point 4, 1. Okay. And so if that's the point 4, 1, then I know the point 1, 4 must be on the inverse. And so I'll come up here and I'll put a dot there, and you want to make sure your dot is a different color. Okay, 1, 4. And then you could do the same thing. Say here, this is the point, what is this, 3, -2, which means that on the inverse, you're going to have it -2, 3. She's going to put it up there. Okay. Now, the other way you could do this is using symmetry and reflecting it. So you could do it this way. If you look at this point right here, here's your line of reflection. So you're going to mirror it so it's exactly the same distance on the other side. Okay, and that would work as well. And you could do that with, well, this point, there it is. So you can count like diagonally. It's 1, 2, like 2.5 blocks away. So 1/2, 1.5, 2.5. This point, yeah, right here. Oh, we didn't reflect this one. So this is 1, 2, 2.5 points away. So I'm going to go blocks away diagonally. 1.5, 1.5, 2.5. So right there. Okay. And then this point, looking for the right color. That is the 0.22. And if you reflect it, you would get the 0.22. So that's going to reflect onto itself right there. So it really doesn't matter how you do that. And this question was honestly trying to get at both of those concepts, where you could find the coordinate and switch the ordered pair around and then plot that. Or you can draw the axis of symmetry, which is the line y equals x right here, and just use like the mirror image part of that to get the graph of the inverse. Okay, either of those is fine, and again, this problem taps into both of those ideas. So there you go. So you should see that symmetry, and hopefully I can grade that fairly easily. So there we go. There's a review. It took me 35 and a half minutes with all the explanation. I did some of the problems I did out more than once. So hopefully when you're taking the test, you are not going to be looking at more than like 45 minutes of time. Okay. So as always, you know where to reach me if you have questions about this or anything else, and I will see you next time.